This is what is called a factorial. For example, 5 factorial, it would equal 5 times 4 times 3 times 2 times 1. You start with whatever number that is, you count backwards to 1, and you multiply the numbers along the way. That's how this works. So if I ask you to read this out loud, this is read as 5 factorial. This does not say 5. Thank you. So with that in mind, let's go back to number 11 from earlier today. So this was number 11 from today, and what I actually want to do is I want to stop and I want to do a similar situation but with way smaller numbers. Suppose f of x is x cubed and we want to find, let's say, the third derivative. Watch and learn something here. The first derivative would be 3x to the power of 2. Now the next derivative, the second derivative, f double prime, I'd have to go 2 times 3. I know it's 6. Let me just leave it as 2 times 3. And then the derivative after that, the third derivative there, it would be 2 times 3, because this would just fall off. The x would fall off. But notice that 2 times 3, that's the same as 1 times 2 times 3, which is the same as 3 times 2 times 1, which is the same as 3 factorial. So if you have a degree 3 and they want the third derivative, the answer is just going to be that degree factorial. So in general up here, if you have the 100th power and they want the 100th derivative, you know what it's going to be. So based on that observation, you know that if you found the first derivative, it's 100x to the 99. And then the second derivative would be 99 times 100, x to the 98, and then 98 times 99. All the way down, you can predict what this would say. This would just be 1 times 2 times 3, all the way down to 100, which is the same as 100 factorial. So in general, this works. Just make sure that it says x to the power of n, and they're asking for the nth derivative. If that's the case, it would just be that power n factorial.